Hey folks, so your notes yesterday look, maybe something like this that you had a minor arc like CB. So CB is a minor arc. And then you had to use three letters CDB, right? CDB for a major arc. Okay, major arc. And if they asked us a question like, what's the measure of arc CB? And they told us this is like 120 degrees. We said, well, this is 120 degrees right out here. The arc is equal to the central angle, right? So this is the central angle right in here. Now, get ready. We're going to talk about a topic that, man, I honestly, as I started teaching math, like 30 years ago, uh, radians were not super clear exactly what they were. And I'm going to try to make it clear to you right now. I think you can do it. I think you can understand what a radian is. It's okay. So let's talk about the 120 degree angle first. Okay, so I'm going to move this back to 120 degrees. And in this program, I wasn't really able to select the red arc and tell it to measure the arc. I had to kind of trick you guys. I really copied this text out here. This is just text that is referring to this angle right in here. And that's important. I attached it to this point. And yesterday was kind of like a diamond shaped point. I hope that didn't confuse you. Like, what's that diamond doing on there? That rhombus or that parallelogram, I mean, it kind of looked like that. Some people were asking me about that. And it was just a place for me to attach the text to. Um, because it has arc length. Arc length is definitely something I can do over here in the tools. I can measure the arc's length. That's the distance from B to C. But what I want you to notice is I'm about ready to change units right now. And I want you to do the same thing on GeoGebra. You go over here, you click on that. Let me get off that for a second. You click on this wrench and you go down to settings. And then you got to click on this little curve shape, this cubic function, to enter where you can change the units for the angle to radians. Okay, so I'm going to change it to radians right now. Keep in mind, and this is going to be a subtle point, you might be saying, well, yeah, okay, I get it. Like the arc angle is the same as the central angle. And it just changed units, right? So maybe that's where you start in your brain. You say, okay, it's not degrees anymore, it's radians. I don't know what radians are, but they're actually seen kind of all over the place in the shooting sports. So if you ever learn how to shoot a rifle, scope is quite often in milliradians. Some scopes are in MOA, which is minute of angle, but some are in milliradians, and that's popular in the precision shooting world. So radians are used in all over math and science and all kinds of places. So, anyways, let's talk about this. Let's move this around a little bit. Okay, what do you notice as I move this over really close to a semicircle? To a semicircle, right? When I go to a semicircle, it just says pi radians. Why does it do that? Well, notice the way I have it set right now. The distance from the origin over to the circle is 1. So if I crank this all the way around, it's going to get really close to 6.28. 6.28. Let's look at Desmos for a second, and let's do a little calculation. If I had a radius of 1, the diameter would be 2, right? Well, let's just look back at our picture here. Isn't the diameter from one side to the other, isn't it 2? It's 1 to the origin, 1 out to the other side of the circle. So the diameter is 2. So if I switch over to Desmos and I go 2 pi, it's 6.28 all the way around the circle. So shoot, I keep going over to that picture over there. 6.28 all the way around the circle that has a radius of 1 or a diameter of 2. So if I go halfway around, I'm at 3.14 or pi, right? So here's halfway around. It's interesting how I move my cursor out there and it says, okay, you're halfway exactly. So we're going to call that pi radians. Now notice what the length of the arc is. The length of the arc is pi. Yeah, okay. Well, they're measuring the length of that arc as a way of measuring the central angle. Now, here's the crazy thing. Here's the thing that's going to blow your mind. When I change the radius, the length of the arc is going to change right over here. It's going to get longer. So watch this. If I change it out to here, like 1.5 or 2, why is the arc getting longer? Because the distance from B over to C has increased because the radius just increased. You know, if I make the circle really large, that distance is going to get really, really much bigger. So the length of the arc and the angle measure in radians match up when the radius is 1. And this is a really important idea in higher levels of math. It's called the unit circle because it could be like 1 foot, it could be 1 meter, it could be 1 centimeter, it could be 1 inch. Whatever the unit is, doesn't really matter. It's just 1 of whatever that unit is. So it being the radius is 1. So that makes the diameter 2. That makes the whole circumference 2 pi, or halfway around 1 pi. So this measurement for the angle matches the arc length when the radius is 1. So let's add that to our notes right now. If this radius was 1, okay, then the measure of the angle is the same as the length of the arc. Now, it's a little tricky when it's 120 degrees. It was super easy when we went halfway across the circle, right? And we said, okay, well, pi is over here because if I went all the way around the circle, if I went all the way around, the circumference is equal to pi times diameter. And if the radius equals 1, the diameter equals 2. So the circumference is pi times 2, or 2 pi. Okay, so I get that this distance right here all the way around is 2 pi, and halfway is 1 pi. But what's 120 degrees? So here's how you can figure that out. You could do something like this. You could say, well, 120 out of 360, that's equal to 1/3, right? That's a third of the circle. So this is step 1. Step 2 is you take a third of 2 pi. The whole circle is 2 pi, right? So I end up with 2 pi over 3. That's the radian measure right here, 2 pi over 3. Now, some people like a little formula. And this kind of two-step process, it can be broken down to a formula. So here's what I'd like you to think about. Isn't it true that if we go all the way over here to 180 degrees, isn't 180 degrees equal to pi, really? 180 degrees is at the same location as pi radians, right? So let's say I want to get a form of 1, a special form of 1, the number 1. And the way I'm going to do it is I'm going to divide both sides by pi. So if I divide both sides by pi, these pi's over here are going to divide out, and we'd have the number 1 on the right side, and we'd have 180 all over pi. This special form of 1 could be used to convert from radians to degrees. So to convert from radians to degrees, we could use this multiplier right here, this multiplier. So I want to try one right now with you. So let's say you had 5 pi 6. Okay, so let's say it says the arc angle, or the measure of the central angle. It says like the measure of angle A is equal to 5 pi 6. And they want us to convert to degrees. Convert to degrees. Okay, so here's what I'm going to do. If one fell swoop, I can do something like this. I can go 5 pi over 6. And if you want to think about it like in a science term, this is radians right here. And what I'm going to do is I'm going to multiply by 180 degrees divided by pi radians. And what's going to happen, if you want to think about it this way, is the radians kind of cancel out, and then the pi would divide into that pi, right? And you could do all this on Desmos, of course. 5 times 180 divided by 6, or we could go 6 into 180. That gives us 30, right? You could do this arithmetic. You could say, okay, that's going to go into there 30 times. So I'm doing my division before I do my my multiplication, now I go 30 times 5 and I get 150 degrees. Okay, let's try another one. Let's say they tell me that the radian measure of an angle, okay, so this was an example right here. Let's call it example 1. All right, let's label this guy. This is example number 1. Okay, let's do example number 2. Let's say they tell me the measure of angle A equals, let's say, so, I don't know, 5 pi thirds. Okay, so let's say 5 pi thirds instead of 5 pi 6. Well, let's see, what could I do here? I could go 5 pi thirds times 180 over pi. All right, now, you know what we should do is let's highlight this guy in our notes. This right here is a super important little converting factor. You can multiply by 180 over pi to convert from radians to degrees. So that's what I'm doing right down here. I'm converting from radians to degrees. And so let's see, how can I do this multiplication? Well, the pi's are going to divide out. I go 3 into 180 is 60. 60 times 5 is 300 degrees. Okay. Now, sometimes people are super good at fractions, and you see that 5 pi thirds is 2 times 5 pi 6. So you could take 2 times 150 and get 300 degrees. That's another way of doing it. So that's how we convert from radians, convert 2 degrees from radians to degrees. Now we're going to do the other way. We're going to go from degrees to radians. Okay, so here's how we do that. Well, look, up here, we divided both sides by pi. We said that 180 is the same thing as pi, okay? So what if I divided both sides by 180? Now I'd have 180 divided by 180 equals pi divided by 180. These 180s would divide out to 1. So now we got 1 is equal to pi over 180. But notice what I got now. I got radians over degrees. So let's say I had, I don't know, like 100 degrees, okay? And I want to convert that to radians. So if I multiply by a special form of 1, okay, so when I say special form of 1, something equivalent to 1, I'm going to multiply by pi over 180 because degrees are in the denominator, radians are in the numerator. The degrees here are going to divide out. And now we have a problem to do on Desmos. You could do 100 divided by 180. It's probably best to simplify the fraction because a lot of times they want you to have a fractional part of pi, you know, so my tens, I could divide 10 into each one of these. I could divide 2 into each one of those, and I get 5 pi over 9. I hope it's clear that, like, why is pi in the numerator? Well, we're multiplying pi times 100. It's like 100's over 1. And you take 1 times 108. That's how you multiply fractions. It's like the easiest thing to do with fractions is multiply numerator times numerator, denominator times denominator. So 5 pi ninths radians would be the measurement of that angle. I mean, it's crazy. Like, you know, as a beginner, you might not have any idea where the heck is 5 pi ninths. So let's just think about that for just a moment. If this is where pi is located, right? Let me add some notes here. So if 180 is where pi is located, 180 degrees, same thing as pi radians. Well, where would 5 pi ninths be? Well, that's a little bit more than halfway to pi. So 5 pi ninths might be something like right in here, right? Halfway would be straight up here, halfway to pi, I should say. So this right here would be 5 pi ninths. Okay. Man, this is the first time you've ever seen this. So if this is like, what? Your brain's kind of freaking out a little bit. Hey, give yourself a break. You know, just do the best you can on homework. These two methods right down here is what you're going to want to refer to do today's homework, okay? There's a bunch of questions that ask you to convert to degrees. There's a bunch of questions that ask you to convert to radians. So follow these little processes down here and see what you can make out of it. Now, if you've just learned that when the radius is 1, the arc length is equal to the angle measure in radians, you've learned quite a bit. Okay, so I'm happy that you're giving it a shot. Okay, and trying to understand what radians are. If you're just hanging on by a thread, then just try to follow that little process that I just showed you on how to convert from radians to degrees and so forth. It only works when you have a radius of 1 though, right? So if the radius gets bigger, you got to think about how does that impact the radian measure that you're given and the arc length, the actual arc length. Like if the radius was twice as big as 1, then this arc length is twice as big as whatever the radian measure is. It's actually kind of easy to deal with. See, like if I took 2 times pi, I get 6.28. If I made it 3 times bigger, now it's 9.42, which is 3 times pi. If I made the radius 4 times bigger than 1, now it's 4 times pi for that semicircle, right? Let me see if I can zoom out so you can see it. So the angle measure is still pi radians. I'm going halfway around the circle, but the radius is now 3, so my arc length is 3 times that angle measure. Hey, thanks for watching my video. Man, I hope radians and degrees are a little bit clearer on what they are, what the relationship is. We'll practice a bunch in class, okay? Thank you.